Howdy, it's Tubal Cain again after my summer hiatus, and we're now into the September of 2010, just in case this video is around for 20 years. I'm going to start a series of videos that I'm going to call Machine Shop Tips, and we're going to start out with taps and tapping. There'll be a couple on that, and then we'll get into threads and threading with a die and various things like that. But today the subject is taps, the different kinds of taps and tap drills. There are many different kinds of taps. They're made of many different materials. I've put a small sample here on the bench of what I've got, and then I have everything in multiples. You know, like there's a whole drawer of taps of various sizes, and hundreds of taps here in these drawers of all sizes, and then there's other drawers on the other side of my shop that have them as well. You can't have enough cutting tools, you know. The first thing I wanted to say about taps is they come in complete sets like this, and this was I think from Craftsman or Ace Hardware or something like that. And the top here is taps, and then the bottom is the dies. And I also have one below that's metric. But this type of set is generally going to be carbon steel. That is, the cutting tools are carbon steel so that they are affordable in a store. Otherwise this might be several hundreds of dollars, but I suppose maybe this is $75 or something like that. But if you have your choice, get the high-speed steel. If they are made of high-speed steel, they will always be marked HS or HSS. If they're carbon steel, they're ashamed of it, and they will not mark it as such. Here's a set of 3 taps, and these are 11/16, kind of an odd size, but by set, what I mean by that is they're all the same thread size, and by the way, these are marked Poland high-speed steel. But we have 3 types of taps within every size, and in my hand now is a tapered tap. Now a tapered tap has about 7 tapered teeth. It allows you to start a hole straight, and since there's a little chip load on several teeth, there's little likelihood of breaking it. These are best when you have a through hole, not a blind hole. Now if you're only allowed 1 tap, and that's what you're going to run into when you go to the hardware store, if you tell them what I'm telling you right now, the teenage girl will not have a clue on what you're talking about. But they're probably just going to have plug taps, and they have 3 or 4 tapered teeth to allow it to start. And if you're on a desert island and you only have 1 tap, it should be a plug tap. And this will go to the bottom of the hole, but it won't thread you won't have full depth thread on the last 3 or 4 threads. And finally we have a bottoming tap, and there's usually only about 1 tapered tooth on that. You will never get that to self-start. You need to use one of the other taps first, and then you can finish off with this. In the smaller sizes, there's a great likelihood of you breaking these, because when you hit the bottom of the hole, there's no cushion, and they break. So we got taper, plug, and bottoming. Taps come in every size, in English and metric and Whitworth and I don't know what else all, but they're all the way from real small ones. This is about a number 2, and they even go a lot smaller than that. These are real easy to break, and then that's the one I was just talking about, and they're going to go a lot larger than that as well. So you have to determine by the blueprint or the job or whatever, the thread size, so that you know what tap to use to either thread the hole or to clean up a hole. Sometimes we use a tap to clean up a hole that has been damaged or has rust in it. There's a whole bunch of other real little ones. One thing I like to do, you know, I make a lot of models. I have a whole set of taps here, and they start at 440 and they go up to about 3/8. But on this little homemade index here, This is handy to have on the drill press or the bench. I have the tap drills in the front row here, and then the corresponding tap for that tap drill, and then a clearance drill. A tap drill, of course, is the hole size that you're going to need in order to tap a hole. For instance, if you're tapping a 1/2 inch hole, you don't drill it 1/2 inch. You drill it 27/64, and that'll give you about a 75% thread depth. On the smaller ones, you might not want to get the 75% thread depth because there's a great chance of breaking it. A clearance drill is the size that allows a bolt to pass right through it. For instance, for a 3/8 tap, we would use a 3/8 drill on the clearance sides, not the tap size. There are many charts that are available, and these are little hand charts, but there's also wall charts and books and so on to tell you what size to drill before you tap. That's pretty important. Some of the taps that were made for consumer use actually had that stamped on it, the size to drill, because people go in the hardware store and they didn't know what they're asking for, and they sure aren't going to get much help while they're there, because all the old machinists are dead. There are all kinds of tap wrenches. The T-handle tap wrenches in many different sizes. They look like a T, and you use a small one for small ones and a larger one for large ones, because you don't want the handle to be any bigger than necessary, because you have a greater likelihood of breaking a tap. Remember, if you break a tap, you need to throw the work away. You aren't ever getting it out of there. You may have a fantasy that you're going to use a Walton tap extractor, but they don't work. So the whole idea is to not break the tap. When you run across dull taps, throw them away immediately. Don't put them back in the toolbox, because they will only come back to haunt you. And then there are other types of tap wrenches in many different sizes, and I have some that are much, much larger than this, but if it's a great big tap, you need a great big tap wrench. And here are some other that I'm going to use on the lathe in the next one when I show you how to tap on the lathe. And here's a spring device that allows you to hold your tap in the drill press or the lathe, and it's spring loaded. If you look in the machinist catalogs, you might see 30 or 40 pages of taps. There's that many different kinds. These are pipe taps. This is a 3/8, and then we're 1.5, and here's a 2-inch. These are quite expensive when you get into the bigger sizes. Remember that pipe threads are always tapered. That's what allows galvanized pipe threads to seal themselves as you tighten them up. So when you get into those pipe threads, it's nothing like regular machine threads. I guess we're pretty much getting away from that kind of pipe anyway, but I still do some of that work. Here's some extra long taps. Sometimes those are called pulley taps, but sometimes you need an extra reach. Almost all taps are made either with a center hole, and that's the hole on the end there that was used when they manufactured and sharpened the tap, but that's often very usable when we go to thread on the lathe or on the drill press, and I'm bringing that up now because I want to show you that later on. Some of them, especially in the smaller sizes, do not have a center hole, but they have a bit of a point on that end. And that is what I was talking about when I mentioned this thing that has a little bit of a hole in the end of it and it can support a tap. This is meant for slightly smaller ones, but I selected some larger taps on here hoping that would show up so you'll know what I'm talking about on when I start to thread on the lathe. I suppose that's enough on taps. You can read a lot more about it because I've just barely touched on taps, and we're 9 minutes into this video. So in the next one I'm going to show you how to tap on the lathe. Be sure and look at my many other videos on machine shop and steam engines and tractors and things like that. Okay, so long for now. This is Tubal Cain.